Hello students, welcome back. So in this part we are going to study about equation of normal in two different forms, that is point form and parametric form, and we are going to also study about the properties of hyperbola. So let's watch the recording. Okay, so let's start with the equation of normal and some properties of hyperbola. So first of all, I will tell you about equation of normal in two different forms, that is first is point form and the second one is parametric form, and then I will teach you about some standard properties of the hyperbola. So first is equation of normal, and in that first is point form, right? So how to write down equation of normal in point form? So if I want to write down equation of normal in point form to this curve at this point, right? So at this point means this point is lying on the curve, on the hyperbola, right? Whenever I am talking about point form, whether it is equation of tangent or whether it is equation of normal, point form means point is always lying on the hyperbola. Okay, now so this will be the equation of normal, right? If I simplify and if I find out what is the equation of normal, I will get this, right? This will be the equation of normal in point form, and this you should remember. Now what will be the equation of normal in parametric form? If I want to find out the equation of normal in parametric form, I will just replace x1 y1 in the point form, right? In x1 y1 I will just replace by a sec theta and b tan theta, which are the parametric coordinates, right? So just replace x1 and y1 by a sec theta and b tan theta. So this will be the equation of normal in parametric form. Now let us study about a few properties of hyperbola. So let us look at what are the properties of hyperbola. So suppose if I draw a tangent and a normal at a point on the hyperbola, it will bisect the angle between the focal radii, right? So what is, suppose this is the hyperbola. Okay, there is this point, this is any general point P. Now if I join this with both the focus, suppose this is S and this is S dash. Okay, so if I draw a tangent at this particular point P, it will be something like this. So this tangent will bisect this angle, that is S dash PS. Okay, so this angle will be bisected by this tangent. So this angle will be equal to this angle. This is the property, right? And similarly the normal will bisect the external angle. If I draw a normal, this normal will bisect the external angle. So if this angle is alpha, this angle will also be alpha. So tangent bisects internal angle and normal will bisect the external angle. Okay. Now the second property is the locus of fit of perpendiculars drawn from the focus of the hyperbola this upon any tangent is its auxiliary circle, right? And this is the equation of auxiliary circle, and the product of this perpendiculars is b square. So suppose this is my hyperbola. If this is my hyperbola and these are the focus, right? So locus of fit of perpendiculars drawn from the focus, right? So suppose this is tangent at any point. This is the tangent at any point, and if I draw perpendiculars from the focus, right? So one perpendicular will be something like this, and the second perpendicular, if I draw it from the second focus, second perpendicular will be something like this, right? So suppose this is N and this is M, foot of perpendiculars from both the focus. This is S and S dash, right? So both this point N and M will always lie on the auxiliary circle. That is this circle, right? Both the points will always lie on the auxiliary circle. And the product of the foot of perpendiculars, right? So what will be the product of this perpendiculars? Product of this perpendiculars means Sn into S dash M. If I multiply this two, this product will be equal to b square. So there are two parts, right? Locus of this foot of perpendiculars. If I find out the locus of this, then it will be auxiliary circle. So this foot of perpendiculars will always lie on the auxiliary circle, and the second part is the product of them will be equal to b square. So both the part you should remember. Now third property is the portion of the tangent between the point of contact and the directrix subtends right angles at the corresponding focus. What does this mean? Suppose this is the hyperbola and here there is a directrix. If I draw tangent at any particular point, any particular general point, right? And where this tangent is intersecting the directrix, let me say this point is Q, So this point P is the point of contact, right? So tangent between point of contact and the directrix. So this PQ, segment of this tangent PQ will subtend right angle at the corresponding focus, right? So this angle will be 90 degree. Okay, so if I join this P and Q with the focus, the angle will always be 90 degree. This is one of the properties, right? And this you can also prove it by finding out, you can take this point is known, right? A comma 0. You can take this point as xy, some general xy, right? You can find out point Q by writing the equation of tangent. This is the tangent at point P. So you can write down the equation of tangent at point P and then you can solve it with x equal to A by E with the directrix. So you will get point Q. Now once you get point Q, you have point Q, you have point P, you have point S. So you can find out slope of PS and multiply this with slope of QS. And this will come equal to -1. If slope of PS and slope of QS is -1, PS will be basically perpendicular to QS. Right, and if PS is perpendicular to QS, the angle between them will be 90 degree. Okay, so this is the third property that we have. Now, the fourth property will be the foci of the hyperbola and the points P and Q in which the tangents meet the tangent at the vertex are concyclic. Right, so suppose if this is the hyperbola. The foci of the hyperbola, right, so foci of the hyperbola are S and S dash, S and S dash, right, and the points P and Q in which the tangent meets the tangents at the vertex. So these are the tangents at the vertex, both the vertex, right, A and A dash. This point is A, this point is A dash. So I am drawing tangent at both the vertex. This is x equal to A, this is x equal to minus A, right. So P and Q are the points P and Q in which any tangents meets the tangent at the vertex, right. So any tangent meets the tangent at vertex. So suppose this, right, so this is the tangent, something like this at this point P, right. So this point of intersections are, let me suppose this point of intersections are M and N, right. So in the question it is said that these 4 points are concyclic. These 4 points are always concyclic, they will always lie on one circle. These 4 points are always concyclic, where any tangent, right, where any tangent is intersecting the tangent at the vertex. So these 2 points, N and M, and this S dash and S, both the foci are always concyclic, so they will lie on a circle. So I hope all the properties of the hyperbolas are clear to you. So students, we have seen how to write down the equation of normal in 2 different forms, and I have also told you about few properties of hyperbola. Now in our next part we are going to study about previous year IIT-JEE question. So do watch the next lecture. Thank you.